Okay, so let's look at how to do optimization in Excel. Optimization is just an extension of goal seek or what if analysis. The only difference is that optimization takes into considerations some constraints. And the constraints are you want to make sure that you don't go beyond certain boundaries. So the constraints are the boundaries that are set that is requiring you to operate within that particular boundary. And so let's look at a typical example. A company is producing chicken jollof, beef jollof, and then pizza. And then we have a total labor unit that's in hours that you need. And you also have profit per unit. You have the time it takes for you to make one. And then we have monthly demands. Now, here is the constraint that I put in red. So the total available labor hours is 10,000. It means you cannot work beyond this in a month. The available production hours, that is the time taken to manufacture all the products, is 1,700. And the next constraint is that don't exceed demand. So how do you need an optimization to be able to deal with something like that? But at the same time, you also want to like maximize profit. So how do you intend to handle something like that? You have to maximize profit. So let me say that all that you were seeing around here, what is it? We had to do all the calculations, or I did all the calculations which are here. The constraints that you have, or the one of the ways to be able to tackle it is to make sure you have your mentally production unit, which is, and then you also have your mentally profit. Then you have your labor hours and you have your production hours. The constraint demand have to list it, which is already here. And then we also have, yeah, the demand constraints are here. That's why they say don't exceed demand. And of course, other constraints that were also given are here. So what I'm going to do is to simply delete what we have here all the way because that information wasn't given. And so we have to make sure that we calculate it. So this is what you would have had. It would have just been empty like this. Maybe let me also remove the sheet. And so when you have a problem like this, together with this information given, you need to break it down like this. And then in breaking it down, let me say that we are working within this circle. So let me come and put borders around it. So when we come to this point, we are looking at the monthly production. And then our monthly production is simply what we have here. So we are not going to do much about that one. Though the monthly production is just going to be that particular figure. So I'm going to paste that over there. Monthly profit. Profit is going to be whatever that we have here on top here. This is our monthly, should I say, the unit profit, and then this is the monthly production. So the monthly profit will be the unit or the profit per unit times the production, which is here. And then we are able to get that. So we can do that across board. So I'll come to this point and say this particular value we have there, multiply by our monthly production. And then we tap enter. Labor per unit is also given monthly production, which is also here. So to get the monthly labor hours, we need to look at the labor per unit, because so that will give us equal, and you tap enter, then run it across, and then you have it fixed. Then the last part will be the time that requires for us to be able to, you know, and so that particular time is also here. So we start with our equal sign and say this, the total demand, which is here. And then we can simply tap our enter key and then run it across as usual. Now, when we are done with this, we need to get the totals, which is also here. Very important. Because the question is saying that, or the demand is that the available monthly labor hours is 10,000. So that's 10,000. So which means the sum of the labor hours in all should, which is supposed to be here, cannot exceed the available monthly production hours, 1,700, which is the total sum of this, cannot exceed this. So let's get the totals across this and let's see. So this is equal to, I'm just going to use the sum function, then highlight the whole of that, close it up and tap enter. And so I'm going to drag that down. And so this also becomes our monthly profit, total profit, which is here. So let me add Ghana cedi notation to it. And to do that, you simply go and click on this dollar sign. It drop down, then come and click more accounting format. You can see the symbol drop down. Start typing Ghana. Then you will see Ghana cedis down here. And then you can add it. Maybe we don't want the decimals, just want an absolute figure. And this is an accounting format. So that's what we'll be able to. And then let's color that particular cell because that's our target cell we want to work on. And so we can maybe something a little bit lighter and make it bold. So that's the target cell. The variables that we are supposed to change are the ones I want to highlight in yellow because they are the only things that we can change, the monthly demand. So when we come, we also have another constant demand. So the demand here that we cannot exceed is this particular values which have been given. That's the monthly demand. But remember, when we use solver is going to actually manipulate or play with the variable that we can change, which are the production unit. But that particular production unit and then demand must also make sure that we don't exceed it. And that is it. So when we have reached this particular point, then we can now use solver to be able to get the rest of the our work done. And what is our purpose? Our work is simply to maximize this particular profit. So to do that, we go to the data tab, come to solver. But if you don't know, if you don't have solver, I think I've shown this video a number of times. Go to file, come and click on options. Then you go to add-ins. So you can see Excel add-ins are here. When you take Google, you can see solver is over there. Mine is already ticked. Then you can click tick and then click OK. Then it will be added. And then when you tap, so under the analysis group, so you tap on your solver. And then when we come here, always make sure you click on reset and click reset all so that you leave everything in. Set objective is our objective here. Our objective is to maximize profit, and this is the total profit that we want to maximize. So where this came and click inside that cell. And then, and to what are we going to? Yes. So you click maximize because by changing variables, the one I highlighted in yellow, the production plan or the monthly production. So I'm just going to highlight all of that. Those are the values we are going to change. And the constraints I've already explained a little bit this side and add one of so you click on the add and then what is the first constraint that you want to the constraint is that whatever that we have here must not exceed this because this is the available, which means this place can only be equal or less than. And then I will say less than or equal to, come to the other side and highlight this. That's the first constraint. I'm going to add the second constraint is that all the production that we are going to manipulate, whatever that happens, be equal or less than, but it cannot exceed this because this is the demand constraint. That's the total demand that we need. So whatever we have here is will also be the same thing. So I highlight that, and then I have to also come and highlight this. And I think any other constraint that we are saying that because we are producing items and we cannot have half, it can be half. So we are also saying that whatever that we have here must be integers. And then I think that should be about all. And then we can now click on solve and Excel will simply tell us how to be able to maximize our profit. Okay, I'm going to use the simplex LP linear programmer and solve it and see. So Excel found an integer solution with tolerance, all constraints satisfied. So let's see. And then as you can see, the maximum profit we can make is actually 307,000. This is, it doesn't mean that we've dropped from 400,000. No, come and check how many chicken jollof we can now produce. We were initially producing 12,000. Now we are doing 4,000, which means the everything factor it in. So we virtually maximize profit by producing less of chicken jollof and then maintaining the rest. Particular solution is fine. Then you click on OK, and then you've solved it. So this is one of the ways through which we do optimization. Now, let me see. There is another one here that optimization questions, they don't come in the form of or the you can actually run a data and then you can have, let's say, just like we have it on top here, and then subject to all these constraints, which could also be equations which are there. So we need to break this down for everybody to understand. So what you normally can do, I just want to be fast about this. So we have our objective function. Maybe I can take that one out. Maybe come to this point and take it out. So first of all, how many variables do we have here? We have three, x1, x2, and x3. So that's what we normally have to do. So the x1, x2, x3 are the decision variables that will have to be changed. So at the moment, let's set x1 to 0, x2 to 0, and x3 to 0. Now, what is our objective? Our objective is to maximize some profit. And this is the equation. So once x1, x2, and x3 are given, or have been assumed to be 0, we can actually calculate our objective value or our which is going to be 0 for now. So, but I just want you to know how we enter it. So you start with equal sign. This is 3 times x1. So you bring your 3 times, oh, sorry, you bring your 3 and then use asterisk times x1. x1 0 here. Plus, then you have 2 times x2. So you have 2 times x2, which is here. Then you have x3. So the same as 1 times, which is here. And then that's all. We tap enter, and then we're going to get 0 for now. It's the same format. The constraint, when you look at the equations, they are in three sections, three parts. We have the equation part, we have the inequality sign, and we have the value at the right hand side. So the constraint 1 here, we're going to say x1, x1. So we start with, at the same time, we start with equal sign and say 1 times x1, which is here, right? Plus 3 times x2. Then we have plus 1 times x3, which is here. And then when we do that, then we can tap enter, and it's going to give us 0. Then we bring the inequality here, which is less than or equal to, less than or less than or equal to what? 9. And so we are going to do that. We put 9 over there. That's what we are going to do for the rest of the the work. So I'll be a bit fast now. So that will be 2, also 2 times x1, 3 times x2 minus 1, and then I can simply tap enter. They are all okay. That one is greater than or equal to, I think, is 2. Then we come to this point to constraint. We have 3, no, sorry, we start times x1 plus, no, it's not plus, it's minus 2 times x2, 2 times 2, which is here, then plus 1 times x3, plus 1 times x. So we tap enter, and as usual, it is also greater than or equal to 5. Then you put 5 on the other side. The rest of the constraints are here. x1 is greater than 0, x3 is greater than 0. So let us just come here and say, let's say x1 here, come to this point, x2, tap last parts, x3, and then tap enter, because they are all greater than or equal to 0. So I'm just going to copy this down, and then this also down, so that we could be fast about it. So now we are done. We have our objective here, we have our decision variables, and we have our constraints here. So now we can use solver to solve the rest. So we click on data, come to the solver function, then as usual reset everything. Where's our objective? Our objective, the set objective, we come and click here. That's what we want to maximize. So we click on maximization, and then by changing what the yellow variable that that's the variable that those are our decision variables, subject to what constraint. So we have some constraints here. Now check the inequality sign from constraint 2 all the way to 6, or greater than or equal to. So we don't have to be doing it one after the other. So I will simply just highlight the whole of this and then come and select greater than or equal to here. Then also select the whole of this. All. Or we can also say that we don't want these, we don't want them to be, so it's about the way we arrange it. But for now, 7, x1, then we can change it to 9. It at 0 if we want to maximize. That is it. So if we're actually items that were, so we have said that no, ignore the production of item 2, 9, this particular figure. So as to how is it. So there are other ways. I think this is practically the same. There's another one here. This is going to take a long time. Other than that, I would have also shown you how to do it. So you have, let's say, grade, grade A, B, up to, or I think this should be A, B, C, C, and then oh, so that should have been A, B, C, D, A, B, C, D, E, and F. Then yeah, I think just copy that. And so let's say this is the labor cost of producing a particular grade, grade A, in Accra, Takura, Tamale, Kumasi, and Ho, then in that order. All right. So you just want to pause is there, and then you want to at least minimize costs. Nothing will be there, and then the constraints, and then the rest of the values, as you can see, they are all empty for now. So all of this will not be there, and then the repeat the whole of this table and come and repeat it around here. And now these are the decision variable. That is why I shaded it yellow. So I just highlight the whole thing like this, and then you go to the home tab. Sorry, you go to your home tab, and then come to this point, and then highlight it whichever color that you want. Yeah, if you want it to be maybe this light. So when you have and the condition is that you want to minimize the total cost. Now this is the labor costs. So to produce one simple, or to produce one bag of grade A cement in Accra, it costs about 34.8 Ghana cedis, 32, Kumasi is 39, Ho is 32.5. Now, terms can you produce in Accra, in Kumasi, or each of the grade in such a way that you can minimize your total cost. Okay. So that is what this is what you're going to have. And the second information you're going to have is the minimum whether the grade A, you can only produce 35,000. Grade B, 9,500. In Accra, you can only produce 20,000. Takoradi, 15,900, and then in that order. And so those are the limits that you have to bear in mind when you want to handle it. So when these values will be given to you, and then you will have to now set it. So that's the minimum country production, or I should have said that's the minimum town production. And then that's the minimum grade production. So I just want you to relate to the data, but this is somebody's data. And so we also have our total items, or our total, then in that order. So now, but this is where all the decisions are going to take place. So at the moment, we actually don't have anything inside those particular. So when we come and we want to look at the total costs here, as you can see, the total cost is going to give us the the total units which are produced here multiplied by the total sorry, each of the cost. So if in Accra, if I'm bags of cement, each bag costs about 34. So I'll multiply 34 by the number here, and so that I'll be able to get the minimum total cost, or yeah, the total cost which is here. So if I come to this point, I can simply, the formula is given, but I can still rewrite the formula so that you understand what I mean. So you have to say, you use the sum product function, all right? So we have sum product, I think, and then use your tab key to finish it up. Where's your array one? This is the first array, and then we are also multiplying. So you put your comma and come and multiply it by array. Then close it up and then to make sure that the total town production is here. So we are actually saying this plus this plus this plus this plus this plus this. So we use the sum function and run it across. And this is what we did. The sum function is there. Just tap enter, and then we run it across, and then we have it because there's nothing inside there. It's the same way here, the total item production. So the total of this. So we just use the sum function here again, and then maybe if I double click, you can see the sum function over here. So you look at where it has been highlighted. So you tap enter. There's nothing in it for now. So we simply just run it, and then we're good to go. So now is to let solver decide how many we can produce in Accra, Takoradi, Kumasi, of each of the grade in such a way that we can minimize our costs. So to do that, we come to our data, come to solver, and then as usual, reset everything. And then what is our objective this time around? This is our objective function in green. So click there. This time around, we are minimizing costs. We are minimizing our cost. And then now we have minimized our cost. We'll click on that by changing, you see, what are we going to be changing? These are our decision variables, why I highlighted. And so those are the variables we are going to be changing, subject to what kind of constraint. Then I'm going to come here and then click add. The first constraint that we know is that we have a minimum grade production, which is here. So if it is minimum, if this particular, the whole of this is the minimum that we can produce, then it can be the total can be either greater or equal to. And come and say greater than or equal to whatever that is also here. Because if this is the minimum grade production, the total we have here, we can actually use greater than or equal to. We cannot say less than or equal to again because we are already talking about minimum. If this was the, we can say that we cannot exceed whatever that is here. But if this is the minimum, we can exceed whatever that is here. Then we, which is that this is also the minimum town production. So which means the total that we are going to calculate here, uh, this should either be less than or equal to particular one, or to that one. Yeah, but it cannot be less. So I will simply highlight that first and say it should be greater than 2. I come and highlight the whole of it, and then we are good to go. Then we add. The last constraint we want to add is that we are dealing with integers, like they are count items, they are bags of cement. So we cannot have half bag. So to do that, we highlight all the decisions that are going to produce and tell solver that we want them to be integers. And they should be integers. And if all is set, then we can select our linear and then come and say that we want to solve it and then see. So solver found a solution. All constraints are optimally satisfied. And so now let's come and look. But I'm not seeing any effect. I'm not seeing I should cancel it and then choose a different one. So let me solver. Yeah, so maybe I might have made a mistake somewhere that I'm not. So these are my decision variables. Yeah. And then, okay, let me rather use, and then, what again, convert constraint sets. Or maybe, if I'm not, maybe it might be the constraint that I did not set it fully. So let me see if I will cancel it. Check where I'm getting it wrong. Okay, so let me see once more. So the constraint can actually, okay, or so let me just reset all to this point and click on this. The cost. And then we say subject to these variables which are here. And then we add the constraints. Then I'm not sure that should be the correct proper, this is the proper way. Add, I'm not sure of what I'm doing. We add, and then we just come here and say we want to select it as an integer. And then, okay. Then try to see if we can solve it. Yeah. So I think the constraint selection, the sign, instead of using less than or equal to, I use greater than or equal to because we are minimization. So here we have had all experience satisfied, optimally satisfied, but now we can go how many we can produce. In some places, we don't have to produce anything. And then in that order, then we are good to go. This is also a minimization problem, and this is how we solve what is it, or when we are dealing with optimization. And so examples that I will have what is I need to. So I can just click OK, and then I am good to go. And so this will be our total minimum cost, about 2.5 million. Then in that order. There are there are others that we could have also looked at. Let's say we are looking for total profit in this particular portion. Let's say there's a furniture we're looking for. How many can we produce here? In order to maximize this particular profit which is here. And the profit. And so if we are looking at what, so somebody's producing furniture using different. So you look at this and also try it, and then whatever that you are finding available. So this data I'm getting it from other friends who are also doing the same work, and then I get it from there. So acknowledgement to all of them, and thank you. If you want to know how to be able to do this, let me explain briefly. So you have oak tables, pine tables, oak chairs, and then pine chairs. The chairs made of different materials. So for you to be able to make one oak table, you need, this is the material you need 17 feet of the oak material and 0 pine, then in that order. The available material that you have is 150 feet for the oak, and then 210 for that of the pine. So how many can you produce here to be able to maximize profit? Here, here, here. And those are the decision variables. First of all, they've also said that the available material, which is here, this is the available material. So which means you can't exceed this. So the usage here, that's one of the things that we need to pay attention to. The usage here should mean that if I am producing, let's say, 5 tables here, five this time is this, as this time is this time is this, should be the total that I have used for, in the case of oak, give me, and that should not exceed the available material that is there. So to be able to do that, you can simply say equal to, use the sum product function, which is here, and use the tab key. So the first array that you're going to do, yeah, the number, the production plan, that's the total number. But make sure you're going to do that for the two. So you fix it. Function key down F4 to fix it. And then that's your first array. Then the second array will now be this. And then you are good to go. Yeah. So I'll close that and tap enter. So I'll simply just drag this. I hope you understand why I log, because this was going to multiply by this and then also multiply by this. So those will change, but this one will remain fixed. That's why I fix it. And so we have that particular used. Now let's come to our total profit. Our total profit is also the same sum product function. And what are we going to do? Because this is our unit profit. And whatever that we produce here, if we produce 10 in oak tables, so you multiply 10 by 40, that should give you plus this and this, plus the same thing, and then you are able to. And so because we are going to be multiplying and adding, we'll use the sum product. So again, we are, and then we bring our comma, and then also do this, and then we close it up and tap enter. So at the moment, we give us 0. So, but this is the actual targets that we want to. So let's make it bold. So now let's use solver to be able to see whether we can solve it. So I'm going to reset all and then bring it to this side. What's our objective? Our objective is this. Okay. And then we are maximizing by changing what variables, the one I highlighted here. Those are the variables we're going to change, subject to some constraint. The constraint is saying that whatever that we have here must not exceed this. So it can be less than or equal to that, but it cannot exceed it. So it's already less than and equal to have been selected. And then we add. What other constraint is there? We cannot produce half table. So I'm going to say the whole of this must be integers. So we click OK. And I think let's select simplest linear and then solve. So I found a solution and it's saying that don't produce any of the tables, just produce only chairs, oak chairs, and then pine chairs, and produce 30 of oak chairs and then 200 of pine chairs. And then we are going, in that case, we can make a profit of 3,600 Ghana cedis. And you can see all constraints are met in that order. And so we are utilizing all the materials that we have. And then that is it. So we've solved it. Now, once we have it solved like this, let me try something new, particular profit to about, this is 3,000 to let's say about 4,000. Okay. And these are still our decision variables. So I'm going to still be there, come to date solver and come to this point and say that our objective function is already selected. But this time around, we are increasing it to a value. So come here and then specify that value. 3,600, let's say we are increasing it to about 5,000 Ghana cedis by changing the same values which are there, subject to whatever, everything that is here is okay. Solver could not find a feasible solution, and so I'm going to cancel it. I was trying to see whether if I can easily let solver increase this particular profit, given the constraint that are there, but the constraint limited it. It could not. It could not actually be able to do that, and then, so that is it. So maybe if we had changed the constraint and say that okay, let's come back to solver and see the constraint, for instance, instead of less than, we could say greater than. We can actually do more than this and see. So I'm going to delete this constraint. And then add it. Then this, and then click OK. And then let's see if we can solve it. Yeah, solver found the solution this time around. You notice that because initially we said this point we cannot, and then that particular limit, together with the profit that we have, we could not reach 5,000. So we allowed solver, and solver said that in that case, let's produce about 312 chairs and a 0 pine chairs, then produce some table 7, and then a pine table 7, and then 1 pine chair. They'll be able to make a profit of about 5,000 Ghana cedis. And then the total used material will be about 1,577 of the oak and then 210 of the pine. And that's it. So we can also click OK here. So I think the video, take your time, watch it, pause, then practice, and then that's how it's going to be. Thank you, and I'll see you in other videos. Bye-bye.